Alright, welcome back to Anton Math. Now in our last video we talked about exponents. Now it's very natural after talking about exponents to talk about kind of the reversal process of taking a power, and that's taking a logarithm, right? So this video is about logarithms. Now the way we define a logarithm is we usually write this kind of cursive log, and we'll have some base. In general I'm going to use b, log base b of a number x equals y. And remember this kind of double barred, double arrow, that means is an equivalent statement to b to the y equals x, right? So what log base b of x means is what power do I need to take b to in order to get x, right? So b to what power equals x? So the answer is y, right? This is going to be equal to the power that I need to take b to in order to get x, right? So the first thing to notice is that it's clearly not defined for b equals 1, right? So not defined for b equals 1. So think of it this way. If I have 1 to the y equals x, well, if x is anything other than 1, then there's no possible solution for y. If x is equal to 1, then I can choose any y that I want, and this is going to be true, right? So it doesn't have a unique solution. So it either has infinitely many solutions or it has 0 solutions. So we don't define this log for a base equal to 1. We need a base that's equal to some positive number other than 1, okay? All right. Now let's do some quick examples just to get us back in the familiar mode with these logs. Let's say I have log base 3 of 9 equals y. Well, by our definition, right, these are examples. By our definition, that's the same as saying 3 to the y equals 9. So I have that y, which is equal to my log base 3 of 9, is clearly going to be equal to 2, isn't it? So in other words, log base 3 of 9 equals 2. That's the same thing as saying 3 squared equals 9. All right, pretty simple, right? Easy stuff. All right, let's look at another one real quick. What if I have a bigger base than my number? Let's say I have log 25 of 5 equals y. Well, by my definition of logarithms, that's the same as saying 25 to the y equals 5. Now I know that the square root of 25 equals 5, and I can write that as 25 to the 1/2, can't I? So I have that my log base 25 of 5 is going to be my y. My y here is just 1/2, isn't it? Or in other words, 25 to the 1/2 power equals 5. All right. Now we have a couple of properties with these logarithms, and this is why I went through all those properties with exponents in such detail, as these pretty much just follow from our properties of exponents. So we have properties. Now in math, we always introduce a concept and then we introduce properties. And properties are your best friend. If math is a game and you're trying to figure out this game and you really want to win this game, properties are the rules of the game. If you don't know the rules, there is no way that you're going to be able to win, right? So we have some properties. The first one is if I have log of a product, so log base b of a product u times v, that's going to be equal to log base b of u plus log base b of v. And I'll leave this one as an exercise. Just go back to those properties of exponents and the definition of log, and this just kind of jumps out at you. Okay, now the next one, this one I'll probably derive for you. If I have log base b of x to the a, that's equal to, I can pull this a out in front, that's equal to a times log base b of x. Now this follows from my property. I'll kind of do a little aside over here. This follows from my exponential laws that we went over. Let's just say I have this, let's just look at log base b of x is going to equal some y, right? So if log base b of x equals y, that's the same thing as saying b to the y equals x. Well, if b to the y equals x, that means that x to the a equals b to the y to the a, right? Or equals b to the a times y. So what's this saying? This is saying that if log base b of x equals y, then log base b of x to the a, right, using my definition the other direction, this is saying that log base b of x to the a is equal to ay, right? And I know that y, we already defined my y up here as being log base b of x, right? So this is just a log base b of x, right? So there's a little derivation for you of this second one. Let's come back. If I combine these two things together, I get that log base b of some number u divided by some number v is equal to log base b of u minus log base b of v, right? And this, let me make some space over here. Right, this one comes from the fact, look, log base b of u over v. We know that from our exponential laws in the last video, this is the same as log base b of u times v to the negative 1, isn't it? Now using my first property, that's the same as log base b of u plus log base b of v to the minus 1. And now using my second property, I can pull that exponent minus 1 out in front. So that's the same as log base b of u minus log base b of v, right? So it all kind of clicks together, doesn't it? Now I need an extra requirement here, right? We always want to be careful whenever we have a fraction, and it's kind of implied here. If I'm even talking about log base b of u over v, I assume that u over v is a defined number. But just to be safe, we need to make sure that v is not equal to 0, right? We know that. We can't have a fraction where the denominator is equal to 0. Now I have one more property, and that is that log base b of 1 equals 0. And this is for all b, right? Now that just comes straight from my definition, right? This means log base b of 1 equals 0. That's the same as saying b to what power equals 0. Or sorry, b to what power equals 1. And that means that my y is always going to be 0, right? I know that b is not going to be equal to 1 because we said it's not defined for 1. So the only way that b to some power equals 1 is if that power is 0, because b is not equal to 1. Okay, so these are our properties. Now I'm going to do one additional note. I'll go ahead and make sure you've taken these notes. I'm going to go ahead and go to a clean board here. An important note, we always have these two kind of identities, right? And this just comes, again, directly from the definition. Log base b of b to the x is equal to x. And b to the power log base b of x is equal to x, right? You can kind of think of these as cancellations. Log base b cancels with the base b in an exponent, or the base b cancels with log base b in an exponent, right? And I'll let you take a look at these. These again, plug these into the definition, and it's just going to pop right out to you, right? In fact, yeah, these are pretty much the same thing. So let's do some quick examples. Okay, let's say I have 8 to the log base 2 of 3, right? Now I can't cancel just yet because this 8 is not equal to 2, right? I can't use this cancellation property up here, but I know that 8 is a power of 2, so that's the same as 2 to the power of 3 log base 2 of 3. Well, I know that if I use my exponential laws that we derived in the last video, this is the same as 2 to the power 3 log base 2 of 3. Now I can't cancel this 2 and log base 2 yet. I have the same b's, right? I'm almost there, but I need to get rid of this coefficient of 3. So I'm going to use my property of logs. Just like I can take an exponent here of my x and put it out in front of the log, I can take a coefficient and put it in as an exponent. So this is the same as 2 log base 2 of 3, and I'm putting this 3 over here now, 3 cubed. Okay, now I have this cancellation law. I can kind of think of this as canceling, so this is just going to be equal to 3 cubed, or 9. All right, let's do one more, and then we'll finish up for this video. Let's use our other cancellation law. Let's say I have log base 5 of 125. All right, so log base 5 of 125, this one's actually a little bit easier. Log base 5 of 125, that's log base 5. Again, I want to use this cancellation, so I want to get the same base of an exponent in here. And we know 125, that's the same as 5 cubed, and so we're already there, aren't we? We're ready to cancel. I know that log base b of b to the x is x, so log base 5 of 5 to the 3 is just 3. All right, so that ends this video on logarithms. Now I have one more video for this kind of introductory section, so we will see you there.